The Fermi paradox. Where is everyone in the universe? Ever find yourself staring up at the night sky, just soaking in the sheer vastness of it all? It's like a giant, twinkling canvas that makes you feel both tiny and incredibly curious at the same time. I mean, think about it, billions of stars, countless galaxies, and who knows how many planets out there. Have you ever wondered, with all that possibility, why haven't we bumped into any alien neighbors yet? Where is everyone? Today, we're diving into one of the most intriguing puzzles of our universe, the Fermi paradox. It's a question that has puzzled scientists, philosophers, and pretty much anyone who's looked up and thought, are we really alone? So grab a comfy seat, maybe a cup of your favorite space-themed beverage, and let's chat about it. First off, let's give a shout out to the man behind the paradox, Enrico Fermi. Enrico Fermi was an Italian-American physicist, a real genius who made significant contributions to the development of quantum theory, nuclear and particle physics, and statistical mechanics. But perhaps one of his most famous contributions is a simple yet profound question he casually posed over lunch in 1950. Where is everybody? And just like that, the Fermi paradox was born. The immensity of the cosmos. All right, let's set the stage by trying to comprehend just how enormous the universe really is. Trust me, it's going to make our daily problems feel hilariously tiny. Tears of joy. The scale of the universe. Our cozy little home galaxy, the Milky Way, is a barred spiral galaxy that's about 100,000 light-years across. To put that into perspective, if you were cruising at the speed of light, which is, by the way, about 300,000 kilometers per second, you'd still need 100,000 years to cross the Milky Way from one side to the other. And that's just our galaxy. Now, get this. The observable universe is estimated to be about 93 billion light-years in diameter. Within this mind-blowing expanse, astronomers estimate there are around 2 trillion galaxies. Each of these galaxies contains billions, if not trillions, of stars. And orbiting around many of these stars are planets, some of which could be eerily similar to Earth. Probability of life elsewhere. Given these astronomical numbers, it seems almost impossible that we're the only intelligent life out there. This is where the Drake equation comes into play. Developed by astronomer Frank Drake in 1961, it's a probabilistic formula used to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. The equation looks something like this. N equals R asterisk, Fp, Ne, fluid, Phi, Fc, L, where R is the average rate of star formation per year in our galaxy. Fp is the fraction of those stars that have planetary systems. Ne is the average number of planets that could potentially support life per star that has planets. Fl is the fraction of planets that actually develop life. Phi is the fraction of planets bearing life where intelligent life evolves. Fc is the fraction of civilizations that develop a technology that releases detectable signs of their existence into space. L is the length of time such civilizations release detectable signals into space. Many of these factors are still unknown, so the equation doesn't give us a definitive number. But even with conservative estimates, the equation suggests that there should be dozens, hundreds, or even thousands of intelligent civilizations out there. So, with all these possibilities, Fermi's question echoes louder. Where is everybody? Understanding the Fermi paradox. Let's circle back to that fateful lunch in 1950. Picture this. Enrico Fermi is sitting with some colleagues, chatting about recent UFO sightings. They're discussing the likelihood of faster-than-light travel and the possibility of interstellar voyages. Suddenly, Fermi blurts out, "But where is everybody?" His question highlighted a glaring contradiction. Given the high probability of extraterrestrial life, as suggested by the sheer number of stars and planets, why haven't we found any evidence of it? The Fermi paradox isn't just a question, it's a challenge to our understanding of the universe and our place in it. It forces us to confront the possibility that either we're alone, a solitary spark of consciousness in a vast cosmic dark, or there's some reason why we haven't found, or been found by, our cosmic neighbors. Possible explanations. All right, time to don our detective hats and explore some theories that might explain this cosmic silence. Ready? Let's dive in. The rare Earth hypothesis. One possibility is the rare Earth hypothesis. This theory suggests that while simple microbial life might be relatively common in the universe, complex intelligent life, like us, is exceptionally rare. Earth has a unique set of circumstances that allowed complex life to flourish. A stable, long-lasting star, our Sun, that's not too hot or cold. A planet located in the habitable zone, just the right distance from the star. A large moon that stabilizes the planet's axial tilt, creating a stable climate. A protective magnetic field generated by a molten core, shielding us from harmful cosmic radiation. Plate tectonics that recycle carbon and regulate the climate. Maybe Earth hit the cosmic jackpot, and such a winning combination of factors is incredibly rare. If that's the case, advanced civilizations might be few and far between. The Great Filter Theory. Next up is the Great Filter Theory. The idea is that there's some sort of hurdle, or filter, in the evolutionary timeline of life that is incredibly hard to overcome. This filter could be anywhere along the path from pre-life to intelligent life capable of space communication and travel. Some possibilities for the Great Filter include the initial appearance of life from non-living matter, abiogenesis, the evolution of simple cells into complex cells, the development of sexual reproduction, the emergence of multicellular organisms, the leap from intelligent life to a technologically advanced civilization. If the Great Filter is behind us, then we've already passed the most significant hurdle, and perhaps we are among the first intelligent civilizations. If it's ahead of us, well, that might mean most civilizations wipe themselves out before reaching a stage where they can explore the cosmos. Kinda gives you chills, doesn't it? Grimace. Technological limitations. Another explanation could be good old-fashioned technological limitations. The universe is mind-blowingly vast, and the laws of physics as we understand them impose some strict speed limits, like the speed of light. Even sending a message to our nearest star system, Proxima Centauri, which is about 4.24 light-years away, would take years to get there and back. Maybe other civilizations are out there, but the immense distances and the time it takes to travel or communicate mean we're just missing each other. It's like trying to have a conversation with someone on the other side of a massive stadium without a phone or megaphone, not exactly efficient. Self-destruction hypothesis. Now, here's a theory that's a bit of a downer but worth considering. The self-destruction hypothesis. This idea suggests that intelligent civilizations might inevitably destroy themselves before they can reach out to others. Think about it. Technological advancements often come with increased capacity for self-destruction. Consider our own history. Nuclear weapons capable of wiping out humanity multiple times over. Environmental degradation and climate change threatening global ecosystems. Biotechnologies that could potentially create pandemics. It's possible that the window of time in which a civilization is capable of communicating across the stars but hasn't yet destroyed itself is incredibly narrow. Zoo hypothesis. On a lighter note, let's talk about the zoo hypothesis. This one speculates that advanced extraterrestrial beings are aware of us but have chosen not to make contact. Why? Maybe they're observing us like animals in a zoo, hence the name. Perhaps there's some sort of cosmic rule or prime directive that prevents them from interfering with less advanced civilizations until we reach a certain level of maturity or technology. It's a bit like us watching wildlife documentaries. We observe but don't interfere. Alien life is unrecognizable. Lastly, it's entirely possible that alien life is so different from what we expect that we simply don't recognize it. We tend to assume life must be carbon-based and require water because that's what we know. But what if life exists in forms unimaginable to us? Think about organisms based on silicon instead of carbon, or beings that exist in the plasma of stars, or even entities that aren't confined to physical bodies at all. If that's the case, our methods of searching, like listening for radio signals or looking for Earth-like planets, might be entirely missing the mark. Human efforts to find life. So, what are we humans doing to solve this cosmic mystery? Let's dive into our quest to find extraterrestrial life. Search for extraterrestrial intelligence, SETI. The SETI program has been at the forefront of this search since the 1960s. Scientists use massive radio telescopes to scan the skies for signals that might be artificial in origin. Basically, we're eavesdropping on the universe. Satellite dish. Over the years, SETI has scanned billions of frequencies across the cosmos. While we've had some interesting signals, like the famous "wow" signal in 1977, we haven't yet found definitive proof of extraterrestrial communication. But the search is getting more sophisticated with advances in technology. Exoplanet discoveries. Thanks to space telescopes like Kepler and TESS, we've discovered thousands of exoplanets, planets outside our solar system. Some of these are located in the habitable zone of their star, where conditions might be just right for liquid water and, potentially, life. Discovering exoplanets is a game-changer because it helps us narrow down where to look. Instead of scanning the entire sky, we can focus on these potentially habitable worlds. Advanced technologies and future missions. The future looks bright for our search. The James Webb Space Telescope, JWST, which launched recently, is set to revolutionize our understanding of the universe. It can analyze the atmospheres of exoplanets, searching for biosignatures, indicators of life like oxygen, methane, and water vapor. There's also the Breakthrough Listen project, funded by billionaire Yuri Milner. It's the most comprehensive search for extraterrestrial communications to date, using some of the world's largest telescopes to listen for signals across a vast range of frequencies. And let's not forget missions like Mars rovers and probes to icy moons like Europa and Enceladus within our own solar system. These missions aim to find microbial life, which would be a monumental discovery in its own right. Philosophical and cultural implications. Beyond the science and theories, the Fermi paradox carries deep philosophical weight. It forces us to reflect on our place in the cosmos. Impact on science and philosophy. If we are alone, then life is incredibly precious. The sole spark of consciousness in a dark universe, a thought both terrifying and awe-inspiring. It places immense responsibility on us to preserve and cherish life. On the flip side, if we're not alone, it would fundamentally change our understanding of life, consciousness, and our role in the universe. It could answer age-old questions and perhaps introduce new ones. Humanity's place in the universe. The Fermi paradox humbles us. It reminds us that despite our technological advancements and knowledge, there's still so much we don't understand. Whether we're alone or one among many, it encourages us to continue exploring, learning, and striving to be better stewards of our own planet. Recap of major points. So, let's recap our cosmic journey. The universe is unimaginably vast, with billions of galaxies and potentially trillions of planets. The Drake equation suggests that intelligent life should be out there. Yet, we haven't found any evidence, leading us to the Fermi paradox. Possible explanations include the rare Earth hypothesis, the Great Filter, technological limitations, self-destruction, the zoo hypothesis, and the idea that alien life might be unrecognizable to us. Humanity is actively searching through programs like SETI, exoplanet exploration, and upcoming advanced technologies like the James Webb Space Telescope. The paradox has significant philosophical implications, challenging our understanding of life and our place in the universe. Final thoughts. The Fermi paradox doesn't just ask, where is everybody? It asks us to consider what it means to be alive and conscious in this vast cosmos. It pushes us to look both outward into the infinite universe and inward into our own existence. Maybe the silence is because we're among the first. Or perhaps the cosmos is teeming with life that's just too far away or too different for us to detect, at least for now. One thing's for sure. The quest to find out is one of the most exciting adventures we can undertake. So, what do you think? Are we alone, or is the universe bustling with life waiting to be discovered? I'd love to hear your thoughts and theories. Drop a comment below and let's get the conversation started. If you enjoyed this cosmic exploration, give this video a thumbs up, share it with your fellow space enthusiasts, and don't forget to subscribe for more deep dives into the mysteries of the universe. Until next time, keep looking up and stay curious. Glowing star.